So it's kind of hard to hear you. I think I heard 3/4. I think you're jumping one step because you see this last column here. It actually says 3/4 for us. So it sounds like you know the answer, and you're actually skipping one of the steps and getting your answer, which is fine. Again, this is third grade kind of review. So if it seems a little slow, then slow for what you understand, and that's understandable at this point in time. We'll get into fourth grade stuff here shortly. But looking at this problem here, okay, we outline this square and we cut it up. And if we wanted to shade only one of these pieces, what is the size of that one piece that's red there, Sarah? Do you know?
Three.
So let's go back to our part and whole. So we have part over whole. How many parts are red, Sarah?
One.
Yeah, so there's one part that's red. Now, how many parts are there in the entire square?
4.
There are 4. So each of those pieces is 1/4 of the whole. Do you see that? Okay, very good. Now, how did we go? This is for this is open to everyone. Thank you, Sarah. How did we go from 3 shaded parts, 1/4 is the size of each part, to 3/4 as the total shaded? How did we work from one column to the next to get our answer? Camila?
We got 1/4 because one was shaded. I mean, you colored in one and you did part and whole, and one was not shaded out of 4. So one part and 1/4. And then our answer was 3/4 because altogether it's 4, but 3 are shaded.
Right. So very good explanation. Thank you, Camila. You can think of this as 3 is the number of shaded parts. Right? That 3 on top, I'll try to draw a better arrow. 3 on top is the number of shaded parts. And then this 4 on the bottom is total number of parts. So the number on top is the number of shaded parts. The number on bottom is the total number of parts that you could shade for that unit, right? Total number of parts that you could shade in that one square there. But we have 3 of them shaded out of 4 possible. 3/4 or 3/4 is our answer. Great job, Camila. Great job, Sarah. Fernando, do you want to help us with problem number 3?
Yes.
Okay.
There's
Go for it.
There's 2 shaded. There's
Okay,
2 shaded.
Okay.
And one 1/3.
Yeah, 1/3. Because if we were, let me backtrack a little bit for those that may not have tracked that. We're trying to find the size of each individual part, so only one piece. Okay, there's 2 that are shaded in, but when we're only looking at 1, there's 1 piece out of 3 possible pieces, so 1/3 is the size of each of those parts that were cut up. All right, and Fernando, what would be our answer in the end?
3 of 2.
So remember, the number of shaded parts is on top. How many are shaded?
2.
2 were shaded out of how many possible?
3.
Yeah, so 2 of 3 are shaded. So do you know how to say that fraction?
2 of 3.
You could say 2 of 3 or 2/3. You heard that? Thirds. When we have 3 on the bottom, so we have 2/3. Shaded in. Yeah, very good. Thank you, Fernando. Let's keep on moving. Let's look at 4. Who can help me with 4? The 4th one down. Let's go to Malia here.
Four.
So for problem number 4, what's the number of shaded parts there?
3.
How many are shaded in? Yeah, so 3 shaded in. What's the size of each of those parts? So if I were to only draw in that blue box there, what's the size of each individual square?
4.
So how many of those individual squares, the blue squares, would you need to fill the entire rectangle?
5.
So you need 5 more. Let's look at this real fast. How many squares are there in total? The area of that rectangle.
8.
Yeah, there are 8 squares that make up that rectangle. So when we have our part over whole for our fraction, we would put 8 on the bottom because the whole thing is made up of 8 parts. So there are 8 pieces that make up the whole shape. So when we're making our fraction, we have some number over 8 because there are 8 pieces in our rectangle. Now, how many are shaded in blue, Malia?
1.
1, right? So we have 1/8 is the size of each individual part. Now I'm going to go back and get rid of my blue shading here, and let's look at the gray shading that they gave us. So if we're trying to come up with a number that represents the total amount shaded in gray now, what would our fraction be?
2.
So we take our number of shaded is on top.
3.
Yeah, there are 3 that are shaded. Out of how many total parts?
8.
Yeah. 3 shaded out of 8 total parts. So we say this is 3/8. Okay, does that make sense?
Yeah.
All right, there's a little pattern here that I'm going to stop and share with you. Do you see how we can take the total number of parts right here, and we can multiply it by the top number there and get the top number there? Same with here, 3 times 1 equals the number on top, 3. 2 times 1 gives us the number on top of 2. 3 times 1 gives us the number on top of 3. And do you also see how this bottom number here, this 4, just carries on over? 4 carries over, 3 carries over, 8 carries over. Do you see this pattern here? You're multiplying the number on top by the amount that is shaded to get your top, and then you carry the bottom number over. Okay, let's look at 5 here. Let's use purple. Okay, who can help me with 5? Elizabeth, do you want to help with 5?
Four.
Okay, so there are 4 shaded parts. What's the size of each piece?
1. 1. 1/6.
Yeah, great job. How did you get that?
By counting the whole rectangle.
You counted all the squares that made up the rectangle? Great job. So we have 4 shaded regions. We have each piece is 1/6. So what's the number that represents the total amount that's shaded?
4, 6.
Yeah, 4/6. Great job, Elizabeth. Nice work. Also, Elizabeth, you're 2 away from hatching your Pokemon. So keep on working hard. You're close. 2 away. 2 away. Awesome job. Okay, this next 2 here are a little tricky. Okay. Now here's the thing. When we were finding the total amount of pieces that made up each rectangle up here, we only had 1 rectangle or square, right? So for 1, we only had 1 big rectangle or square in that case. 2 was 1 big square. 3 is 1 big rectangle. 1 big rectangle, 1 big rectangle. But now down here for 6 and then 7, there are 2 squares and 2 rectangles. Okay, so we're still, when we find the amount, the size of the piece that makes up the shape, we're only looking at how many pieces make up 1 square. How many pieces make up 1 rectangle? Because each of those squares and rectangles represents 1 hole. So we're actually counting into 2 holes here, counting into 2 holes there. Okay, so just as a heads up, let's walk through it and see what we find. So who can help me with this first column here? How many shaded parts are there for problem number 6? Let's go Malia Guerrero on this one.
There are 6 shaded boxes.
Okay, great. 6 shaded boxes. Now, what's the size of each of those boxes, Malia? Now, remember, how many boxes make up 1 big square? Malia, do you know the answer to this one, or do you want to phone a friend?
I don't know the answer.
Okay, that's okay. Let's go to Fernando. Great job, Malia. Let's go to Fernando. So your part and whole. If I shade in 1 red box, then how many are shaded in red? What do you think, Fernando? You're on mute. I can't hear you. I'm not sure if you're talking or not. Sorry.
1.
Yeah, there's 1 part that's shaded in red. Now, how many of those red boxes are needed to make 1 big box?
4.
Yeah, there are only 4 that are needed to make 1 big box, right? Now, if you made the mistake of thinking 8, that's okay. We haven't really worked with 2 boxes here, or 2 rectangles or anything like that. So we're trying to find the amount, the size of each piece in regards to 1 big box, 1 big square or 1 big rectangle. So Fernando's exactly right. Each part is only 1/4 of the total box. Okay, Fernando, I'll go back to you. What is our answer here? What number can we use to represent the number of shaded pieces? Let me erase that. There we go. So the shaded gray in regards to the total. And I put you on mute again because I muted the whole class. I didn't mean to mute you as well.
6.
So
Wait,
6. We need it as a fraction.
And 2.
So what's the remember, we multiply 6 times the top to get our top, and then we carry over the 4. So what's my bottom?
12. 12?
Well, remember, we carry this bottom, the denominator here, we carry that over into our answer. So the 4 actually stays the same.
4.
Yes. So we have 6/4. Okay, because each of these boxes over here is a 4th. And so we have 1/4, 2, 3/4, 4/4, 5/4, 6/4 filled in out of 8 possible. So 6/4 in total. Okay, very good. Let's try 7 here. Okay. Who can help me here? How many boxes are shaded in?
6.
Not quite. And I'm going to go to somebody else, Fernando, okay? Because I want to make sure I'm spreading the points around. You already earned your point for answering the last question, so nice job. Elizabeth, let's go back to you. How many boxes are shaded in gray?
7.
Okay, 7 boxes are shaded in gray. What's the size of each of my boxes?
1.
So let's look at this real fast. If I shade 1 in blue, then how many are blue?
12.
How many are blue?
1.
Yeah, 1's blue. Now, how many of those blue boxes are needed to fill
12.
one rectangle? Not both of them, but one.
12.
What's that?
12.
So there's 12 in total between the 2 boxes, but I'm looking for how many fill just this top blue box. How many in total for the blue box on top?
6.
Yeah, 6. So there's 1 that's blue, and it takes 6 of those blue boxes to fill one big unit box. Okay. So now if we use our little strategy that we had up top where we multiply the 7 by the 1, what's our top number here?
7.
Yeah, so, oops, my thing just kind of glitched out. 7, and then what do we do with the bottom number?
6.
Yeah, very good. 7/6 would be our answer for what piece or how much of, there we go, how much of the 2 rectangles are shaded in. So there it goes. So 7 total. We have 1, 2, 3, 4, 5, 6, 7 that are shaded in, and we're working in sixths. So each one of those boxes is 1/6. So if we have 7, we have 7/6. Okay, let's move on to the homework real fast. Okay, I want to give you a chance to look through it. Identify and shade fractions. What fraction is shaded? Explain your reasoning. Now, this is no different than what we just did in class, right? No different than what we just did in class. So who can tell me, let's do this first problem together. Who can tell me how many of these gray boxes in problem number A, problem letter A, excuse me, are shaded? Eileen, let's go to you. I haven't heard from you much today. How many are shaded?
Six.
Yeah, we have 1, 2, 3, 4, 5, 6 that are shaded in. So 6 are shaded. What's the size of each of those pieces? Like, what's the size of block number 1 right there?
1.
Okay, so 1 on top. There's one part that's shaded in blue. They're outlined in blue. Out of how many possible pieces?
8.
Yeah, there are 8 possible pieces. So each piece is 1/8 of the total rectangle, right? So if we were to write a fraction that would represent how many are shaded, what would our fraction be?
1/8.
So each of these blocks is 1/8. So we have this one here. That's 1/8. This is another 1/8. There's another 1/8. Another 1/8. Another 1/8. Another 1/8. So how many 1/8s are there in total?
6.
There are 6 1/8s in total. So our answer would be what? Do you know? What fraction could we say?
1/6. Mr. Ross,
Yep.
I had to go to the bathroom. Did I just put the computer here?
We're going to be done in just 1 second. Can you hold it?
Yeah.
So, Eileen, what's the total number that's shaded?
6.
Yeah, there are 6 that are shaded, and then how many total blocks are there that make up the rectangle?
8.
There are 8. Right, so the fraction that we would need, oops, that was ugly, is right there. 6/8, because there are 6 that are shaded out of 8 possible. Right?
Mhm.
So the homework then, you have a B problem, you have a C problem, and then there is another page here. Okay, the second page, you're mixing what we did today and what we did yesterday. We partitioned yesterday and on Thursday before that, where we cut up the diagram or drew the dashed lines, right, into equal parts. And then I want you to shade how many parts there are that are shaded. So it says 3/8. I want you to partition this shape and draw the shaded in regions. Okay. Okay. So we are finished for today. I know we went a little bit long. I'm sorry, but some days are like that. Do we have any questions on what we covered today? Okay, I'm going to stop recording real fast.